Okay, ready to go?
Yep.
Okay, welcome to our weather discussion for today. I'll give a little bit of a discussion about the current weather, and then Patrick Bay will talk a little bit about the forecast. This is a perfect place to start. It's the water vapor image for the last several hours. Is it, or is this the week?
This is the week.
The whole week, okay.
Yeah.
So we got a couple of interesting features. If you can stop it when we get back to the beginning, Pete, I always find it difficult to talk about it as it's running, just so I can get myself set. Yeah, right here. Okay, so this is a week ago today, and at the time, the flow was more or less zonal across much of the United States, if I recall. I think it's kind of reflected here in the cloud picture from the infrared, the water vapor channel. And you don't see anything of particular organization in the Atlantic tropics, and there's nothing particularly robust in the flow, even to the west. A little bit of an upper vorticity maximum right in there in the water vapor that you can kind of see. Let's go forward, and I'll pick out a couple of features that start to go. So here's one of them, a descending upper trough over the western states that takes shape. This is now Monday, and you can see that downstream of the axis of that trough, and we'll look at this in other forms as well, there's some cloudiness and some organized precipitation. Remember, we had a rainy Monday, Tuesday, and Wednesday this week. Particularly Monday night, I think it was, that rained fairly heavily over us. But it was maybe a little bit exaggerated in the forecast. I don't think we ended up with as much precipitation as it looked like we might get. But anyway, still, nothing particularly well organized in the tropics on Monday. Let's keep on going, Pete, thank you. Then you can't really see it, so stop right here, please. You can't see it so obviously. We'll look at this a little bit more in some observations. This little bit of a dry strip over parts of Wyoming, Utah, and leading into something, once it starts animating again, you'll see this has got a cyclonic circulation to it. And don't do it yet. There's a developing upper frontal zone in this location, and that gets itself organized into what is a, kind of a couple of day long cutoff trough. And that'll be the main focus of what I talk about as we move forward. But watch this kind of convective clump over the northern coast of South America. So let's go a little bit further forward. You can see this in kind of a broad southwesterly flow over the longitudes just to our west. Something begins to get itself organized here over the islands of the Caribbean. Let's go. And then there you go. This is the beginning of, and stop please, this is the beginning of Hurricane Raphael. And we'll say a little bit about Raphael as we get further along. And then, a very sharp upper feature, and not always so easily to illustrated on this map, simply because maybe not all of you have experience with it, but let's keep going forward. This is 2 days ago. And then here's this strong, look at that yellow spot right there on the border of the Gadsden Purchase area of Arizona and California. And that is really dry air. And that's only there because it's been subducted down from the stratosphere. So we'll see what that structure looks like to produce that. Meanwhile, Raphael has just crossed western Cuba, across the Florida Strait, into first the eastern southern Gulf of Mexico. Let's watch what happens to Raphael. It explodes. Okay, so this thing right now is 95 knot wind speeds are maximum. They expect a little bit of intensification so that it'll get into the 100 to 110 range. That's a Category 2, so it's right now on the border between a Category 1 and Category 2 storm. It's very compact, and it's over the same waters as the more devastating storm that affected parts of our country earlier in October. And so, but nice eye for a while, and then it gets clouded over again as we go forward. So, meanwhile, in response to the presence of an upper trough, which we'll see in just a minute in the 500 millibar movie, we get this really dramatic cloud growth over the south central plains, and there's forecasts for as much as almost 4 feet of snow in parts of New Mexico at elevation, and widespread snow in eastern Colorado today, even though it might be kind of a wet snow there. But so they're kind of beginning to see a winter type of situation. We are not yet. So, as you'll see. Okay, so that's a long-standing overview. Let's go now, Pete, to the visible satellite image over the last several hours. We could. So we see some of the same features. Here's Raphael, just north of the Yucatan Peninsula. It's going to sit in the Gulf of Mexico. This is maybe the last hurrah for the warm waters over the Gulf of Mexico. They've been very warm this year, 2 or 3 or 4 degrees above normal over a widespread region. Milton did not do damage to that warm pool. I don't know off the top of my head how deep it is. That's the ocean heat content. I suspect that's also at a record. And so there's nothing particularly dangerous for Rafael right now over the next couple of days. It's going to spin around in the central Gulf of Mexico. Luckily, it hasn't hit the continental United States yet, and maybe it won't. But then you can see this wide cloud area over the southern central plains, and you can see the center of the circulation appears to be right about on the Texas-New Mexico border, right about there. And widespread cloudiness across much of the southern plains as a consequence. Maybe even some high clouds coming in on the northern periphery over us. But otherwise, beautiful weather for us. I mean, it's been a gorgeous couple of days. So the sun is shining even after Tuesday, which is nice. Okay, so most of the rest of the country, though, pretty clear. The northeastern United States, fairly clear. Nobody's particularly cold yet. I didn't update. I'm going to update my 850 cold pool every couple of weeks, not every week. You're probably bored with it already. I don't want to make you more bored. But we were, remember, number 3 out of 77 years. And I've seen no evidence this week of any particular cool downs around the hemisphere. So we're at least that warm, probably, maybe even more, towards the top 1 or 2 spots. I didn't check. I was preoccupied. So we're going to spend some time looking at both the current structure and maybe the prior structure of this, maybe a little bit into the future as well. And that'll be much of the forecast discussion. Before we do that, though, can we go to the Pacific satellite movies? And we'll have to go to the infrared for that. Okay, so you can see it's not particularly well-organized flow across the, at least the eastern and central Pacific basin today. A couple of other things I noticed. The ITCZ is dead in this longitude band. There's nothing really firing up there in the western hemisphere. And so a poorly organized, ragged cyclone, remnants of one, making landfall on the coast of British Columbia. We saw yesterday, you can still see evidence of this today. There's a circulation center here to the east of Kodiak Island off the Aleutian chain in Alaska that was a little more robust looking yesterday. But this is look at the aerial extent of the circulation. Okay, Professor Morgan may well be coming back to the University of Wisconsin in the next few months, and we'll re-engage in our conversations about the intensity and devastation wrought by storms. I think something like Rafael, which would fit on a postage stamp right here in terms of its size, is nothing quite like these beasts. And Michael and I have had a long-standing argument about that. This looked better yesterday, but it's still impressive if you look past the boring nature of the clouds and remember how much air is being controlled by something at the core of that circulation. It's a lot of air. It's being moved around. There's a big anticyclonic wave break over the central part of the Pacific, and you can see some of that evidenced in the clouds moving here. And that gives, of course, the normal, beautiful day in Hawaii without surprise. Okay. But there's nothing particularly robust upstream. It looks like that might change in the next several days. And it's not because, the lack of activity is not because the jet stream is not invigorated. You'll see that when we go to the 300 millbar map. Okay, Pete, can we go to the 500 millbar map? The super Pete, of course. We don't use anything else. In fact, let's get ready. So let's use the movie, not just the image. But let's not look at it until we get to the last one. We want to start at the current time. Okay, thanks. Okay, so here's the current time. 7 a.m. this morning. A cutoff low over New Mexico. The coldest temperature at the core is analyzed to be minus 27.3. The coldest observed temperature is minus 26. So that's the GFS analysis pointing in a little bit colder at the core. So this is a deep, cold core upper low. Remember, we have Rafael right here in the Gulf of Mexico. And at the same time, just several thousand kilometers away, a wintertime upper level low. And that's because Rafael is way out of season. It shouldn't be happening here by early November. This thing is also anticipatory of the season. It's a little bit ahead of schedule. So it's an anomalous little feature. It's also cut off from the broad westerly flow, which is kind of more strikingly obvious this week than it has been on any of the prior weeks. And I'm thinking about the intensity of the winds. And at a glance, that's conveyed by just the geopotential height gradient, which is very tight at 500 millibars across central and southern Canada. And it's wavy as well, but not unduly so. And it's cut off this feature to the south. And so a natural question is, upon looking at this, how did it cut off evolve? I mean, that's kind of why I wanted to look at the movie. Before I do, I'll just point out that, unsurprisingly, where the jet is strong, there's also very strong and obvious baroclinicity. There's 10 degrees of temperature difference between the northern and southern portion of this band in the isotherms. So that is pretty continuous all the way across the Pacific, from well offshore of British Columbia to the Gulf of the St. Lawrence. So that's a wavy baroclinic jet, and that's wintertime. Okay, no doubt about that. So how did this thing, or did it? Maybe you don't know, maybe I don't know. How did this thing get divorced from the polar reservoir of the cold air? It's hard to make a lot of cold air in the middle of a 500 millibar load. You gotta just make it rise, and that's not a good place for the air to rise, so probably did get orphaned. So let's go back like 2-3 days. And don't look at anything till we stop. Okay, so here's Tuesday. So here's what it looked like on Tuesday. The cyclone that we still see some evidence of spinning around over Kodiak Island was much more robust on Tuesday. That was a main feature. And look at the baroclinic zone associated with it, even at 500 millibars. Very strong, and that's the cold frontal zone. So that's the cold front of this deep cyclone. Imagine the cold front of the surface must have been all the way down here off the coast, because they slope backwards into the west with height. And Z gave a nice discussion of the frontogenesis associated with that, and it reached all the way up to 300 millibars, if I recall. And then the warm front to the east is also evident in the baroclinicity, and that reached about to 500 millibars, I think, when we looked at the cross-section of that. But it's this baroclinic zone that gets itself kind of organized as we move forward in time. And at its southern extent is this troughiness over Idaho and Wyoming. And that led us into our kind of rainy day on Tuesday. It's actually a combination of two troughs, this feature to the west and this one that was already fairly well established over Kansas and Oklahoma. So we woke up Tuesday to a kind of a drizzly, rainy day. So let's step forward, Pete, if we could. We'll go one. Looks like the complexion of the flow changes rather dramatically. First, trough number one that was further south 12 hours earlier made its way to about our state. There's the axis of it there by 0Z Wednesday. One almost loses trough number two as a short wave because there's this broad, longer wave trough that's cut out over the western states. But notice how the baroclinicity is really intense here. In fact, if you compare the prior map to the next, let's not do it, but if you did, you'd find out that that's an intensification, even in the observations. And so something interesting is going on along the western periphery of this broad cutoff trough. Let's click ahead one more time. It continues to get interesting. In fact, I'd say more interesting. Look at how strong that baroclinic zone is now. It's -7 north of San Francisco, or south of San Francisco at 500 millibars. It is -30 at Salt Lake City. So in there's about a 20+ degree temperature contrast. We'll remember that time 12Z Wednesday and take a cross section right through there at that angle when we get to it. I'm in the coldest air, perpendicular to the baroclinic zone, and then into the warmest air. If we get to fly in this field program next winter or 2 winters from now, that's what we're going to want to do, Flora. We're going to get in a plane and get to -30 at 500 millibars and then go southwest and cut through the upper front. It's going to be fun. Drop a lot of sondes and whatnot. It'll be really fun. Maybe we'll do it from 150 millibars so we can see the lower stratospheric front as well. And then upstream of this feature that's kind of developing nicely at 500 millibars is this ridge that's crashing with a positive tilt, crashing over western part of Canada. Let's go one more time to get us to Wednesday night. And by then, you can see that baroclinic zone on the western periphery of this evolving cutoff is remaining quite intense. Same range actually, -29 to 8 across that gradient. And it's now that we start to worry about a real substantial event that's going to occur in just to the west of the southern plain states in the intermountain southwest. Let's go one more time, Pete. And here it looks almost like our current maps. It's still a day ago, but there's a cutoff with a cold minimum of -28-ish right in the middle of that over western Arizona, eastern Arizona. And what it's done is effectively migrate maybe 2 more clicks to get to the current time. 2 more clicks, it's migrated to New Mexico. And let's go back 3 clicks, because at the 3-click time, you still can see a tenuous connection between this trough over Ontario and this appendage of it to the southwest over the Four Corners area. Maybe one more time prior to this is even more obvious. Yeah, there's this broad trough axis and this ridge that's cresting and crashing in the western part of Canada, coupled with the vigorous dynamics tied to this feature all by itself on the southern part of the trough, cuts this off. So 2 more clicks, forward, sorry. It's almost cut off and then it's completely cut off. And it just sits there. The rest of the baroclinic flow is passing it by. So I said a word I use all the time, it's an orphaned upper low, and everybody laughed in 452 yesterday. I've just used that adjective all the time. But that's what it is, it's orphaned. Nikhil.
So does the dynamics associated with the trough itself help it kind of dig like southwards? Like aside from the ridge pushing it south?
Yes, I think so. I think that's absolutely the case. So we go back a couple of clicks, maybe you're thinking the same thing I am, maybe one more. So, yeah, okay, that's too many. Let's go forward, right there. So here's this broad trough axis. There's a lot of interesting subsidence going on this side. So and that's what's forcing the upper frontogenesis. Then there's ascent over here, but when we go to 300 millibars, we'll see a big jet right in this region, not surprisingly because the baroclinic zone is strong. And the jet's stubby. It only has this length, maybe. So at the jet exit region, the air is rising, and that's right where the coldest air already is. So you're gonna just make it colder by ascent. And that helps to cut this thing off, because you make this colder, you intensify the vortex nature of it. And so that, in fact, let's go to 300 millibars peak at this time if we could.
It's 12Z Wednesday.
Yeah, 12Z Wednesday.
Oops, sorry.
Don't look at anything. I just discovered that I should do this. This works. Yeah, perfect. All right. Look at that. This is exactly what you said, Nikhil. Look at this incredibly strong jet. It's super geostrophic across the ridge axis, so we're in the range of like 180 knots at the top of this, at the crest of this thing. Early in the winter, wait till the ridge crests like this in February, it'll be 250 knots. And then right on the western side of that same cutoff trough axis, this is the exit region. It's very stubby, so there's a lot of deceleration. There's a lot of ascent right here as a result of that. Some of it's counteracted by the fact that you're not quite yet at the cyclonic curvature maximum, but not all of it. And so the ascent is going to be making it colder right here. Let's click ahead one more time. And the colder it gets, the more isolated that low gets. And then everything, since the ridge is also breaking over itself, it's going to have an easy time repairing and connecting to the flow downstream. So long as you can keep this thing from nudging its way back in, and it won't find its way back north if you keep making it colder at its core. So it's a really interesting, but exactly right on picture of that. And then the other thing is, positively tilted troughs like this flux momentum poleward. So the repair is actually aided by the geometry of the trough. And so the jet is locally forced poleward, and that's because U prime, V prime is positive in this location. Okay, so let's go back to 500 feet. Or maybe we'll go 2 clicks ahead and see what it looks like at 300 before we go back. And notice one thing we noticed from class the other day. The intensity of the winds at 300 millibars rapidly decreases as this thing cuts off. And then you see this nice repair of an almost zonal jet across parts of Canada, and then some waves to the west and one wave off the Atlantic coast. Okay. So pretty interesting. And I'll bet if we go to 200, we can do it just at 0Z or something. This is the underside of a really strong subtropical jet, is my guess. So let's see if that's true. We'll go to 200 to be sure. Don't look at this. Okay, one more. We got to go to right there. Yeah. So there's the strong subtropical jet. We had to go a little higher to find the core of the jet. Maybe we're still not in the core, but that's exactly what I was thinking we'd see. And then and we saw at 300 millibars, the underside of that. Look at this, 172 knots off of the Aleutian Island chain at 200 millibars. Let's click one more time ahead, Pete. Still strong. So that means let's go to the instantaneous 300 millibar map. I want to see if the winds are stronger at 200 or at 300 for that feature. I'd say they're stronger at 200 for that. So that's an interesting, maybe superposed jet structure off the Pacific coast. Okay.
Do you want to go back to 500?
Yeah, but let's do it with some maps that have vorticity on them. And don't give me the granular vorticity, because I want to do some diagnosis here. So let's, GFS,
Tropical or pivotal?
oh, tropical, we want to look at some cross sections. Yeah, tropical, let's do that first. So the regional have to be North America, I think. What did I use to do it? Oh, I did Western US, that was even better, but this will work, this will work. Let's go to 700 millibar temperature, if we can get something like that. That'll probably be in lower dynamics, my guess. Yeah, that right there, okay. And then let's make sure, what time are we at? We're right now, so let's move back in time if we can. Okay, and then, okay, this is getting us in the right range. So let's click forward a couple of times. I'm looking at the temperatures at 700 millibars, which are the red and the blue lines. And so I'm seeing a really intense baroclinic zone right at Lake Tahoe. Let's go ahead a little bit. I want to see what this structure looks like right along that cross section if I can. Perfect. And then let's do PV, and then we'll take a look at this thing. And this was valid on 12, this is today. This is,
It's kind of backwards, so.
yeah, but it's also today. This is not what we were just looking at. So we got to go to another model run. We did the right cross-section, but look at the underlying temperature. It's valid at another time. I'm not sure why it did that.
That's 18Z, right?
Yeah.
Didn't they change the?
So you- Yeah, I think you have to. I didn't realize you have to. But... Yeah, okay, so let's do this now. This will probably give us a decent picture. And it'll,
I'm gonna do it the other way too.
Oh, yeah.
It's west of South.
great. Yeah, so we're starting to get, this is, I was using just 700 millibar theta as a way to figure out where the strong baroclinicity is. And this is the jet core, it's kind of split into two pieces. The isotopes are in green, and there's a pretty strong upper level front there, but it's gonna get better than this. And it penetrates down, the PV greater than 2 is inside this black dashed line, it gets all the way down to 700 millibars. And then notice, there's no surface manifestation of this baroclinicity. There's a stable layer that caps the boundary layer to the what? To the southeast, the southwest. But the upper front's there. Let's click forward ahead a couple of times. This is another one. Let's try this one. No, go back one time, right there. Yeah. Great. Let's see what that looks like. That's a pretty much more robust upper front. But it's not looking like what I saw earlier. Can we get rid of this? I don't know what's going on. Again, confusing times and stuff like that. But it's still a pretty good structure. Let's get rid of 700 millibars and look at the 500 millibar vorticity. I think that's an upper, yeah. Right, no, where is it? Right there. They go from 500 millibar height to Z500. It's easy to get screwed up. Let's back up a little bit in time. Maybe that's what's happening. Yeah, okay. One more ahead. Let's go right there. And this was Wednesday morning, so a couple of days ago. And yeah, same variable. Let's see what that looks like. I think this is what I've seen before. It's not. Anyway, there's a definitely penetration of high PV from the stratosphere all the way down almost to the top of the mountains in some of these places over Southern California. But this is not the structure I saw before, so I'm flying a little bit blind. Let's click that off and go forward a couple more times, or at least one more time, maybe one more. Yeah, this is a different forecast, that's why. Sorry, you'll have to investigate this all on your own. No, wait a minute, Pete. Go ahead, go ahead. This doesn't cut off yet. One more, right there, okay. Let's go back over.
It's not what I intended to do.
Oh, probably interesting, but not relevant.
This mouse is just being weird.
Everything's being weird today. I had a little bit of time to do this morning. I thought I'd prepared it. I guess I was thinking about the wrong places a long time. This will be good though, I can tell right away. No, wrong. Okay, I'm gonna drop this part of the discussion. I don't know what happened yet. I sat at my desk in the limited time I have to think about this morning, and I had a really nice story to tell you, but it's not here in whatever we're looking at. So we'll have to go search for it again privately. I'll tell you the punchline. This whole upper trough that's leading to the heavy snow in New Mexico and Colorado is tied to the prior development of an upper front on the western side of the original positively tilted trough. That whole structure is what cut off and is now sitting near the Four Corners area and giving them their first taste of winter, that's for sure, while we bask in the sunlight of a 55-degree afternoon, so. Okay, that's all I have. Patrick, sorry about that trip up there.
No, that's fine. Can we start with weather.gov? I'll take some cross-sections going forward this storm, but I want to start overview here. So, as talked about, if we could scroll down, this red shading is blizzard warnings over northern New Mexico. This darker red shading is hurricane warnings. The distance between the two are about 1,000 miles. So you go from, this is 4 feet of snow, it's been snowing for 2 days, high winds, to a hurricane at 1,000 miles, which is pretty remarkable. I don't know if I've ever seen that. Hurricane warning and then a blizzard warning right next to each other. Some portions of the same state, like portions of Texas, might be affected by what is going to be the hurricane. This might be some sort of storm surge or wave or something. And then other portions are getting snow. Same state, which is very weird. It's annoying that this is happening over the western portion of the United States, not over us, because if we click just somewhere in the blizzard warning here, there's already been 20 to 30 inches of snow. If we could go to snowfall forecast, this is on top of what's already fallen. You can see some places, you can make this out, 8 to 10 to 12 inches in the northern part of New Mexico. And then if we go back a click, and we'll click on southeastern Colorado, and if we scroll down, hopefully, oh, they got rid of it. They also had a map that was showing places, oh wait, actually if we go back one, maybe it was the wrong area. Try like there. Scroll down. Oh, here, weather story, maybe it's here. And at the top, let's just click through these. There's one specific map I want. Not this one, go to the next one. Not this one. Here, okay, yeah. So this is on top of what's already fallen. Places are getting 11 to 17 inches of snow. And look at the cutoff here. You go from 0 snow, portions of Colorado, you drive 30 miles west and you have 12 inches of snow. And this is coming on, it's been days of this, and this is the forecast going forward. So pretty weird setup. You have Kansas and Nebraska are getting nothing, and then Colorado's getting dumped on with snow. And you know, you can imagine truckers are driving through this and it's raining, and then all of a sudden you have drifts of snow as you're driving through this. So very weird setup and a very sharp gradient cutoff. And then you can see this is probably not the best forecast to put out, I would say. A trace of snow to 8 inches of snow.
That's a Morgan forecast.
Yeah, exactly. That's like, it might snow, or you might get school canceled for the day, you know. Yeah, we don't know. 0 to 6 inches of snow, 0 to 5 inches of snow. Like, I don't even know how useful that is to put out. You might as well just say it's going to snow. We don't know how much.
We have to ask ourselves, is this just a coincidence, or is this a function of Morgan being at the top of the pile here in
It
prediction?
could be. I think he was up early, 5 a.m. making these plots, I think. Oh, sorry, 2 a.m. That seems right for him to be up. So, very weird forecast. And then the reds here are 12 to 18 inches of snow. So you go 12 to 18 inches to 0 in one county. Pretty cool. And so we're going to talk about this storm specifically. Let's see. Could we go back to tropical tidbits, please? And I'll show, if we could go to upper dynamics, I believe, and 330 PV. And if we could step back to just earlier this week. So I'll sort of hit on the same point that Professor Martin showed with how this storm got cut off. This is just another look at it. So if we even go back to like Tuesday. Perfect. You can see this is going to be the beginning of the storm. We have some appendage of PVs that stretches off the map all the way to Canada. If we step forward here, you'll notice we'll watch this appendage keep going south and become stretched out. And it takes on this positively tilted nature, becomes stretched out, and then if we go to Friday at 0Z, you'll see here's our storm. It's just this ball of PV. It's separated from what it once was. And once you get something, it'll just sit there. It'll be slowly eroded by diabatic heating, but nothing's going to move this. So that's why our storm has just sat over Panhandle of Oklahoma, Texas, New Mexico, and dump snow in that region, because if we keep going to like 18Z Friday, which will be about now, you'll see this thing is just sitting there. Nothing's moving it. And as a function, we'll see there was a nice development of a cyclone because of that, and that's where you get the snow and the rain that's been producing so much impacts, especially winter weather over this region here. And one thing I forgot to note, actually, if we could go to the surface map at this time, from our own page, please. It just popped in my head while I was showing this. There's been some weird observations, which I want to point out with this. And I'll do this from our current surface map, hopefully, if it shows me the right thing. And if we could zoom in where that storm is. Here we go, perfect, okay. I'll have to go to another map to show what I want. But you can see there's a very nice rain-snow line where we have rain, it's in the upper 30s in Kansas, and then snow in Colorado. That was that cutoff between the 12 inches and 0 inches. And you can see that snow stretches all the way down towards the panhandle of Texas. But this is where we've had very heavy snow. You can see 33 over 33, 31 over 29. So this is heavy, wet snow that's falling. And imagine getting 4 feet of that. And then having to plow it and drive through it. That sounds awful, but it sounds amazing because snow would be fun, I think, to get 4 inches of snow. And it's early November for these places. Places in Texas are getting feet of snow before we do. We get any snow, which is
It's not
sad.
right.
It's not. It should be, yeah, I agree. If we could go to back to weather.gov, I'm sorry. I'm flipping around here, but then I'll get my story straight. And if we could just go to the home page. Good, thank you so much. Because there's been one place where it's been snowing. If we go to northern New Mexico again, I forgot to point this out, and scroll down, I just saw that. If we scroll down to the map, and click on, I think it's Las Vegas, there's New Mexico.
Yeah, that's right. Las
Hopefully
Vegas,
that's
New
right.
Mexico.
Yeah, okay, let's go to the 3-day history. So Las Vegas, New Mexico, it's been snowing for, a couple days. Look at these dew points. I'll point this out. So it's 25 over -7, 28 over -26, and there's precip falling. Light snow, 28 and a -15 dew point. I don't know how this happens, other than it was very heavy wet snow, very huge flakes, and it's falling through a very dry layer, and it's somehow staying snow as it falls. Very weird, and right now, overcast. I don't know if that's 100% accurate because there is snow still in the area, but 33 over -6. So this is like the classic New Mexico. It's super dry, but then you also have snow falling.
And I wonder if there's just a minus sign encoded wrong here or something. Because if you take the minus sign out, it makes a little
makes
bit more
sense,
sense.
yeah.
The event ends and the dew point depression increases a little bit. Because if it were 28 over 15, it's
That'd be
still
better,
unusual,
yeah.
but at least it would make physical sense.
That's true.
And the relative humidity is 14%. I don't think the relative humidity is 14% at 28 over -15.
I hope not. Yeah, that's a good point.
So-
But nobody has figured this out.
Yeah, it's a really
But
good
these are
thing
the
to bring up.
odds. And if we scroll down, you'll see this has lasted for a couple days now. You can see haze. I don't know what that means, but 26 over -12. So it's been like this for a while.
But Patrick, there is an op that says 26 over go further up, Pete, can you scroll up? Where the relative humidity goes to 8%. Keep going. It's right.
Oh.
Yeah, that's 28 over -26. So if I'm right, this wouldn't work either.
Right.
Because it couldn't be 28 over 26 and have an 8% relative humidity. So
That's true.
maybe that is the way it goes there. I
I don't know. And then if we scroll down, I saw an even more bizarre one. Keep going. Here, 23 over -32,
Unbelievable.
7% relative humidity. It's
And it's
snowing
snowing.
outside, and the visibility is 0.5 miles. That doesn't make any sense. So I don't know if this actually happened.
Yeah.
Unfortunately, we're not there, so we can't
Wow.
verify. But weird.
What
Weird
happens in
event.
Vegas stays in Vegas.
That's right. That's exactly
Or is
right.
that for the other ones?
Yeah, exactly right. Okay, let's go back to tropical, and then I'll put this together here.
Wow.
So I wanted to look at the evolution of this system. First, we saw our cutoff in PV, and we've seen that now. What's plotted on here is the PV and the color shading. I think it's The winds, they don't say the level. I would assume
330.
Probably on the 330.
330 coming to the surface, okay. And then cyclonic vorticity near the surface. So you can see right ahead of where we have that ball of PV, this is where you have really strong low-level cyclonic vorticity. All focused, over where we saw that low pressure already sitting. And we'll watch the evolution of this. If we can see they become nicely, there's a nice separation if we go one back. There's still a nice separation between your main bundle of PV and then out ahead of it is where you get the strong cyclonic vorticity at the surface. I'm using this as a proxy where the storm is, but I'll show you exactly where it's forecast going forward here. But if we go one time forward, you'll see then they become superimposed where you get the PV is sitting on top of the storm here. And this largely cuts off any sort of differential advection that you might expect from the PV in the upper levels. And if we go forward here, you'll see our storm is strengthening a little bit, but if we keep going, now we're into Saturday, cyclonic vorticity weakens. The PV stays the same. We're not having a lot of erosion of it. If we keep going, we kind of lose the signal, and we keep going to, let's just go to like 18Z Sunday, and you'll see that storm sort of disappears in the cyclonic vorticity until now it's moved all the way from the Four Corners region, New Mexico, all the way into where we saw the wave train was, over southern Canada. And then if we keep going like 2 or 3 clicks, you'll see the storm now strengthens. And if we go back one, it becomes an 1,000 millibar cyclone. So it's something. Right now it's about 1,007 when it was over New Mexico. But it takes a long progression across the central part of the United States, even over our state, but it doesn't deepen because you have that superposition between the main PV at the top of the troposphere, your surface cyclone. There's no differential advection. You're not getting any upper level forcing for the cyclone. And we'll look at maybe other ways we might also say that this storm is not going to be anything particularly strong as it moves over us until it goes over the western portion of the eastern portion of Canada and the United States. And then if we go just like 3 or 4 clicks forward, it's not noted, but this storm goes sub 1,000, and we'll see that going forward here. So one way to view that this storm became cut off, it doesn't really do anything over our region. Then once it gets swept up in the wave train is when it becomes a significant cyclone. Now let's go to 500.
Yeah, and the decrease in stability over the warm ocean doesn't hurt either.
That's right.
So that's one
exactly
of the things that really gets it going too.
That's right. Yes, we'll do that one, and then if we could go back to, yeah, this is perfect. So this is about last night. If we keep going forward here, we'll see sort of the same picture. We have a nice strip of vorticity, and it kind of just rotates around this upper level trough. Let's go to 0Z Saturday. And so this is tonight. We can see here's the remnants of what was the upper front in this enhanced region of vorticity. We have a nice upper level low. But this is becoming largely wrapping around the upper level trough, and we'll take a look at the implications of that. But if we could cut a cross section just above the southern border of Utah all the way into Kansas, and we'll get a nice look at the difference in impacts at the surface with this storm. So we can first start with the frontogenesis here. So remember, I'm going all the way through essentially the cold air into the warm air. Here's your barochronicity. That's near surface, and then it stretches up into the mid-troposphere. You can see there's some indication that it's frontogenically active. That's in the pink contours here. And you can see this is the 0 degree isotherm. Where we're in the warm air, that's well above the surface, so it's warmer underneath that 0 degree isotherm. It dips down at some point, essentially right on the border of Colorado and then Kansas. This is where you have heavy snow, as indicated by the bluer shading. This is negative omega, so rising motion. And then you can see all of this omega follows the upslope of the mountains. So you're getting upslope flow. You have decent frontogenesis near the surface. It's warm over Kansas, so it's raining. You get into Colorado, then you get trace to 12 inches of snow somewhere over Colorado. And it's nicely illustrated by this cross-section here. You can see the omega, the ascent, stretches all the way up into the mid-troposphere. So it's pretty decent, even though this storm is 1,007 millibars. You have this component of the mountains that's producing heavy snowfall, heavy rain, just to its east. Now if we go to the PV,
And arguably, the frontogenesis is continuous, because it just might be a
Right.
contour interval is a bad
That's right.
choice, you know? It's go right along the baroclinic zone.
exactly right, yeah. I wish there was a way you could live switch the.
Me too, because these guys are from the tropics, they don't care about frontogenesis. It's too
That's
bad.
right.
I'm glad they tried.
That's true. These are really nice plots, when they work. When they don't, they're just nonsense. So you can see, here's our trunk of PV. This was what the upfront was. It's not really a decent theta gradient, as in the green lines, but you can see it's a nice trunk of PV that goes all the way down towards the surface. This band of PV that stretches kind of parallel to the mountains, this is all diabatically produced. We had really strong, heavy precipitation. You can develop a PV anomaly near the surface, and that aids in increasing the vorticity near the surface and then aiding in ascent near the surface. But you can see this is a nice picture, but there is no real indication that this upper front is existing anymore, as it was stronger earlier, but now as it's rotating around this upper level trough, we sort of lose that nice upper level temperature gradient, but we still have the nice PV trunk. And then if we go to relative humidity and omega, and the same cross section here, now you'll see in the greens is relative humidity, so near 90% we can assume moist. Then we have omega shaded. The pinks are negative omega, so you can see there's a nice area where you have the upslope flow, it's very moist, and you have rising motion, all in the lower levels. Here's your heavy snow. There's sort of a break in between, and then here's your heavy rain. And you can see where we had that region of higher PV, upper level front, it's all from the stratosphere, very dry, and you can see that intrusion all the way down towards the surface. It's sort of separating where you have heavy snow, heavy rain. So a nice look at this storm. Even though as it's decaying, it's still going to produce 12 inches more of snow than it already has. Pretty cool, I would say. And then you can see as all this flow goes up the mountains, it's moist, reaches the peak, it starts going down the other side, it dries out. Sort of opposite what we expect. We would expect the Rocky Mountains, we get warm, moist flow off the Pacific. It's really moist over Oregon, Washington, and then it goes over the mountains and dries out over the plains. This is the flipped, where it's really moist over the plains and then drier over the western portion of the United States. All from this one cross section. This is all tonight at 0 UTC is what it's valid for. And then going forward, if we could get out of this.
Yeah, I really like your point, Patrick, about it's a weak, boring storm at first glance, but there's a lot in there, and there's a lot of impactful weather associated, even while it struggles to survive.
Absolutely, absolutely. And I just looked at the time, so I'll go quick. If we could go to precip moisture, and we'll do mean solar pressure and precip here. So you can see heavy snow, heavy rain. This storm, this Raphael, it's like 983. Who cares? Because it's not impacting any of the land. Here we have an 1,008 low, and it's producing 4 feet of snow. So you tell me which one's more interesting, 4 feet of snow and heavy rain, or a tropical cyclone that's not doing anything.
Heretical.
It's facts. Like, you can see it right here. It's on the map. If we go forward here,
I don't know if Michael's watching.
I don't know.
I hope he is.
He had COVID this week, unfortunately.
You'll see here's a 1,008 cyclone as it moves over our region. We saw that superposition. If we just keep clicking forward, this will be my last point. You can see all the precip dies out. We lose all the moisture. We keep going. Cyclone weakens, and keep going. And keep going, and then it gets swept up in the wave train and becomes something important for Northeast and then parts of Canada. We stay relatively dry. We'll get some rain, but not a lot. And then if we just press forward, maybe let's go to 0. Yeah. You'll see the wave train stays over Canada for a while, and that's the only weather maker going forward in the next 5 to 7 days. You'll see we just keep going.
This is an interesting storm. Watch this
This
thing
is, yeah.
explode over coastal New England. I don't know. It's
Yeah.
really amazing.
Yeah, that's something to watch for sure.
Yeah.
But over our region, nothing,
We'll be
unfortunately.
talking about that next week.
Yeah. So, one more minute. Anything anybody wants to see or questions? Yeah.
noticing on a lot of those northern New Mexico, like hourly reports they put out, like the ones you showed, they didn't have anything for precipitation while they were saying heavy snowfall or anything. They just not measure snow, or is it just because it's severe weather that they're not accurately able to get those?
It's a good question. I'm honestly not sure. I know that a lot of it is automated, so I wonder if there's something going wrong with the sensor because it was so dry, then it's probably that the sensor's just not picking up correct data. Because every other station around that had heavy snow and it's moist and, you know, high winds, but then that station, it's complete anomaly. So it's most likely an error with that station specifically, yeah. Okay. Anything else? Perfect.
All
Thank
right.
you, Jonathan.
Thank you, Patrick. Thanks, Pete.